Welcome and good afternoon. We are ready to get started. First of all, I want to thank all of you for joining today's webinar on Mobilize and Transform Your Field Services with DSI. I'm Deepthi Raju, and I lead the enterprise mobility practice here at SmartBridge. And our main presenter for today is Danny Sang, and he is a manager in our practice. Let's go over the agenda for today's presentation. We'll talk a little bit about SmartBridge, and we'll introduce DSI mobile platform by going over some benefits and highlights of DSI. We will then briefly talk about the approach we used in designing the field service app that we will be discussing today, followed by the bulk of the presentation, where we will be focusing on the features and goals of this field service app and how we implemented them. Now, about SmartBridge services. SmartBridge is a full-service technology consulting firm providing technology strategy and implementation services to businesses in the areas of enterprise systems, business intelligence and analytics, and enterprise mobility. Today's webinar is being presented by the Enterprise Mobility Practice, and Danny and I are part of the Enterprise Mobility Practice, where we enable businesses to establish mobility strategy and roadmap, design, develop, and deploy mobile solutions. We also enable mobile intelligence with dashboards and usage analytics, and also establish device management policies on mobile devices. We do this with the support of our technology partners in our space, and they are listed at the bottom of the slide. I will quickly talk about the services we offer to clients who own and use DSI mobile platform. Our DSI services fall in primarily 4 categories. We offer DSI Health Check, where we review the architecture, configuration, and software versions, etc., identify issues with the architecture or configuration, and then recommend solutions. We offer platform upgrade services where we plan and perform upgrades. It includes upgrading the server, installing the right ERP connectors, updating the devices with the current version of the DSI mobile client, and also updating the applications. Of course, all of this is going to be followed by testing and then deployment of the upgraded applications. We have a lot of experience building DSI apps from scratch, taking them to production. We are experienced in building apps with offline functionality, integration with backend systems, and advanced features like analytics and maps. We also offer managed services both in monitoring and managing services and devices, and also maintaining and supporting applications. With this, I will pass the microphone to Danny, who will be presenting our main topic for today.
Thank you, Deepthi. So DSI as your field service, as your platform for field service apps. So there are many benefits to using DSI as your mobile development platform. Pretty much has everything that you need to be able to build and deploy your mobile applications. We listed some of the most important features of the DSI platform below, and we'll talk about how we use them within our development. So DSI has tools built in to support an offline mode. Since these tools are built into the platform, you don't have to start from scratch if you want to build an offline application. And DSI is also a platform agnostic, so you can run your applications on any platform you want. The development environment is also an event-driven drag and drop interface, so it makes it easier for developers to pick up and learn. And also DSI gives you access to your device hardware capabilities such as GPS and camera. So by the end of this presentation, you should have a good understanding of how these features can be used, and you might even get some ideas for what you want to use in your next application. But before we dive right in, let's take a look at how SmartBridge takes its approach to design and development. We follow the agile methodology to ensure that the end product not only meets the project requirements, but also follows other design elements such as the look and feel, usability, and user experience of an application. We make sure to engage with the stakeholders and end users throughout the project to give them the ability to provide input and feedback. We typically have a 2-week sprint cycle where we develop and then review our changes with the business to ensure that we're all on the same track. The goal is to not have any surprises waiting for us at the end. We started our project off at the concept stage, and this is where we go through a few sprints to quickly mock up the overall design of the application. These are quick and dirty mock-ups, and they're just there to get us a quick understanding of the key features of the application. We then move into the prototype stage, and this is where things get a little bit more refined and the mock-ups start looking more and more like their end state. We spend a little bit more time in the prototyping stage in order to link together the user interactions, and we also show sample data where possible. This is typically where we begin to find a few holes in the process flows, and we have to come up with ways to fill in those gaps. And finally, when we get to the last stage, this is where we will start to have our functional builds that we will use for our QA and UAT. At this stage, the application has been developed with functional features that will require testing by the user groups. So by the end of all these iterative steps along the design process, we can go from a concept stage to a well-polished application in the end. So now let's go into our case study and take a look at the field service application that we built. When we started this project, we met with the stakeholders and discussed how this application should work. We came across with several goals for this application that we needed to build in. The first important goal of this application was to eliminate paperwork and digitize the user's workflow. Our users were sometimes filling out up to 15 forms for each job that they're working on. And these forms include safety forms, inspection forms, maintenance checklists, and site inspections. We needed a way to streamline this data capture process to ensure that all the paperwork is completed and then turned in with their work orders. The next goal was to also capture the user's payroll time along with their work order labor. Previously, the users recorded their shift times using an Excel spreadsheet. But the problem with this is that they're already capturing their labor time on their work orders. So we needed to design a simple way that allowed the users to get on the clock, capture their drive time, and also associate their work order time with their payroll time. The next major goal is to also have an offline capability built into our application. The users are using a mix of tablets and laptops that are equipped with either cellular hotspot or have a built-in cellular modem. These users are often working in remote environments, and they may run into issues where they have slow or no network connection. So we needed to make sure that we design the application in a way so that the users can continue to work even when they're in an offline state. And finally, we needed the application to have an easy-to-use, touch-friendly interface. While some of the users were still on traditional laptops, the organization was moving towards touchscreen tablets. We needed to keep this in mind as we designed all our application screens. The organization also made the decision to have the field service app be their primary data capture tool for all its field users. So now let's get into detail on how we specifically implemented each of these key features. We'll start with streamlining the data capture. So this first feature that we tackled was to eliminate the paper forms and then replace them with digitized versions where possible. There are several key benefits to digitizing the forms in addition to just saving paper. Many times the paper forms aren't filled out correctly, they can get lost, or maybe you can't even read someone's handwriting. So paper forms also don't have data validation against the business rules. Maybe there are required fields that need to be filled out based on a previous value. So we need to keep these benefits in mind as we are designing the forms so that we can make sure to take advantage of as many of them as possible. So how do we start eliminating the paper forms? Well, everyone has to fill out forms while they're on the job, whether it's your timesheet or your expense report. Forms are an important way for users to capture data and pass that information to the next person who needs it. So to start digitizing our forms, we need to think about some of the daily processes that we're doing. Are any of them repetitive or time-consuming? These are the forms that you want to streamline the most, as this is where you'll see the most benefit. Once you've determined the forms and where they fit into your workflow processes, you can start looking at how this data is entered. Can you eliminate that extra field or auto-populate it for the user? Since DSI already knows your login, you can easily use that information to pull up other details such as the user's email address, department, supervisor, and even other past forms. When you digitize the form, you want to find as many ways to speed up the data entry process as possible to make it easier for your users to complete. The best way to capture and hold on to this form data in DSI is to use mobile client tables. Mobile client tables is a quick way to store your data locally on the device. Once this data has been completed, it can then be committed to your backend system. So the flow of the data goes like this. Your user first enters the data into the form. Then the form data gets written to a mobile client table as an in-progress record. Once the form data has been completed, that record can then be marked with a completed status. And then finally, if the user is online at that point, the record can then be written back to your backend database system. By using a mobile client table, we can save off both temporary and completed data even while our system is disconnected. Then when the user returns back to a connected state, the application can check to see if there's any completed forms and then send those up. So at this point, the data can be collected into your backend system and can be used to create other reports and dashboards for the business. We can take a look at a few examples that we developed and give you an idea of how we designed them. So in this sample inspection report, we were able to take all the heading fields and auto-populate them for the user. We do this by taking the user's login ID and then looking up his last inspection report. Since the users are assigned specific vehicles, it's most likely that he still has the same vehicle, so we can populate things like the make, the model, year, and other information that he used last time. If some of these values have changed, then he can still go ahead and update that heading information as needed. But by having the direct access to the user's information, we can use that to auto-populate fields that are required for the form. Our next example is a very complicated maintenance checklist that has a lot of optional sections. The maintenance checklist tries to put all the possible checklist items into a single paper form. The users then have to be trained in order to know what sections need to be filled out based on the type of work order they're working on. So when we revised this into a digitized form, we chose to show exactly the checklist items that pertain to the user's work order that he's performing the maintenance on. We can also do other things like enforce required fields and also do data validation by providing a drop-down list of options to the user. We also took this as an opportunity to make our checklist fully dynamic so that we can add, remove, and reorder items easily by modifying them in the database. Our last example here is of a job safety form. Now this is one of the forms that we were actually not able to digitize because a physical copy of this form needs to be signed and kept on site. However, we did want to implement a solution that can track whether or not this form was completed, and we do that by using the camera on the user's device. So the user would first go out and he would fill out the paper form and sign it and date the form as usual. Then using our application, he would select to record a job safety form. The form would then prompt him to use his camera to capture an image of the form as proof that it was completed and submitted to the site. This image can be stored with a timestamp and can also reference the work order that was used so that it can be pulled up at a later point. So now let's move on to capturing time. So simple time capture can be easy, but time capture can quickly get out of hand once we have all the requirements put together. For this particular case, we had 3 specific requirements that we needed to satisfy. The first one is the user's on-duty time needs to reference the work orders that are being serviced. Second, the user needs to be able to categorize his time as being either part of a work order or as part of indirect labor. And third, the drive time also needs to be captured and linked to the work order as well. So we had to come up with a basic process flow for the user's day. We did this by breaking up the user's timeline into a series of time-related events that occurs throughout his day. When the user first gets into the application, he has to go into an on-duty status in order to start recording his time. After that, the user selects a task to work on. This can be considered as direct work that is on a work order, indirect work that is unrelated to any work order, or it could be marked as drive time for the job. Once the user completes that task, he then allocates that time and he can make any adjustments and add any additional notes. He then selects the next task and he repeats this process throughout the whole day until the end of his shift. At the end of the day, the user can then select off duty to stop recording his time. So for each one of those steps I just described, we had to design a screen to specifically handle that task. So here's, on the left, we can see is the on-duty screen that we designed. When the user first goes on duty, he can select the first task that he is going to work on. Underneath that task, there's also a drive time checkbox that he can use to indicate if this is considered drive time for that task. When the user is ready to move on to his next job, he selects the Change Task button. On that screen, he can see his previous time block as well as choose the next task that he's going to start. You can see that each of these screens was designed to be as simple as possible so that it's easy for the user to learn. And also the large buttons and drop downs on the screen makes it a lot easier to select the options if this were on a touchscreen device. The next screen is our time allocation screen. This screen gives the user the ability to reassign any time, add breaks, or split and remove time as needed. This screen actually went through several iterations until it became really touch-friendly to use. You can see that we have a timeline strip in the center of the screen that resizes as we make adjustments to the time entries. This is there to give a visual representation of how the user's time is broken up. The user can then adjust his time by tapping on the up and down arrows, and he can reassign time to a different task if he selected an incorrect one earlier. As you can see, the user can enter and adjust his time without having to use his keyboard. The only element on this screen is the comment box that requires a keyboard input. And then at the end of the day, the user goes into an off-duty status. Now this is where the user is given one last confirmation of his time, and he's able to make any final adjustments before logging out for the day. Again, you can see that this screen was designed to only show the necessary data that is required to complete the task. So now we'll talk about accessing data in offline mode. So one of the biggest features in our application was to support an offline mode. Since the users are working out in the field, there's no way to tell what type of network connection they will have. The application needs to be able to work seamlessly regardless of whether there is a connection or not. So throughout our design process, we came up with 4 key points that we needed to have in order to support an offline mode. The first is to design the application to assume that we don't have a network connection. Next, any data replications that are done needs to be quick and automatic. Then we also needed to keep our local database as up-to-date as possible. And finally, any transactions to the backend system also needs to happen very quickly. So fortunately, DSI has built-in functions to help us address each of these 4 key points. The first one is data replication. In order to understand the data replication, we need to look at how the data flows. For our application, work order details is replicated from the backend system and is collected by the DSI database server. Then users will perform a replication to pull the data from the DSI database to the mobile client that is running on their device. Once all the data has been replicated to their local device, the users can then go offline and they can work off the local data entirely. Then later throughout the day, once the user has done some updates and returns to an online state, the application can then check for any completed transactions and then send them back up to the DSI server. And that is when the DSI server will take those transactions and then commit them to the correct backend system. So when we are performing these replications, there are two different types to choose from, either a full or partial replication. And there are benefits to each type of replication. In our application, we first use a full replication if it is either the first replication for that day or if there's no local data available. Then we would use partial replications after that to only pull down data that has changed. By using a combination of both full and partial replications, we can significantly cut down on the amount of time that it takes to send data from our backend system to our local database. This helps us keep our local database more up to date by being able to do the replications more frequently throughout the day. While replications can help us get data down to our devices quickly, we also needed a way to quickly be able to send update transactions back to our backend system. So how do we make our transactions seem so quick? Well, this is where we chose to use asynchronous transactions over synchronous ones. The difference between synchronous and asynchronous transactions is that synchronous transactions require a response to come back from DSI telling the application whether the transaction was successful or not. If there are multiple transactions going into your backend system at one time, it may take a while to get this result. Asynchronous transactions, on the other hand, don't have to wait for a response, but instead they will assume that the DSI asynchronous agent is committing them in the back end. This will allow all our transactions to be quickly sent up and stored in the asynchronous agent's queue, and then your users are able to continue working within the application without having to wait. So to recap, what does our final offline solution look like? Well, in order for our devices to operate offline, we had to use data replication to write data to a local device database. To make our data replications run quickly, we had to use a combination of both full and partial replications throughout the day. Then in order to make sure our data is as current as possible, we made sure to perform our data replication operation automatically after each transaction. Since we're using partial replications, this operation can be run more frequently throughout the day without taking up too much time. And finally, our transactions to the backend system needed to be quicker, so we chose to use asynchronous transactions instead of synchronous ones. And by building all of these solutions into our application, we were able to provide a seamless user experience even when the user is offline. So in conclusion, by using DSI, we were able to build a fairly complex field service application for our client. As we look back on this project, we can see that we were able to accomplish all our development goals using this platform. This project showed us that while the DSI toolset may seem basic and simple, you can still build very complex solutions with them. By having a simpler tool set, we didn't have to spend a whole lot of time learning how to use the tools, and instead we simply just started using them and started linking the pieces together. Once we completed our initial build of the application, we were also able to use the DSI platform to deploy builds out to our testers. We were able to create a separate dev, prototype, and QA environment, as well as set up different user accounts and different security groups. Finally, the key that made this project really successful was that our team did a great job of working with the users and stakeholders throughout this entire process. They were involved with us from the very beginning, from when we showed them the first mock-ups all the way through the integration testing. By keeping them involved throughout this whole process, they felt much more comfortable with what we were delivering to them in the end. So that completes our presentation. At this point, we'll open it up for any questions that we may have.
Let's check.
All right. So let's see, we have, okay,
Okay, we have two questions that have come in while Danny was presenting. The first one is about replications. It says, what improvements did you see by using a combination of the full and partial replications?
right. So initially, when we looked at this application, it was mainly just using full replications. But what we saw in the field was that it was taking anywhere from 2 to 3 minutes on average, depending on the type of connection the user has. Sometimes it would even take longer than that. So when we went through this design process, we wanted to make sure that we can minimize that as much as possible. And so once we switched to using a combination of full and partial replications, they still had to do that initial full replication, and that took about 2 minutes. But then our partial replications throughout the rest of the day took only about 10 to 30 seconds, depending on how much data has changed. Next question.
Yeah. So this question is related to the devices that what kind of devices did the field users use in this particular case? What did they use?
So in this particular case, the client actually ended up choosing a Windows-based touchscreen tablets. Some of the users were still using their older laptops, but the rollout in the future is to use Windows-based tablets. So I think we've chosen a few HP and Acer tablets. And most of them don't have a built-in keyboard. Some of them will require a touchscreen keyboard to use.
Okay, we have another question just come by. Can you expand? Are you able to control the order in which the asynchronous transactions are processed?
So the asynchronous transactions, they're sent up in the order that the device completes them in. So you don't really want to, whenever you complete the transactions locally on the device, that's the order that they will be executed by the DSI system whenever the asynchronous agent processes them. So you don't want that order to go outside of the order that you completed them in, because sometimes there may be dependencies between the transactions, and you want to make sure to keep those in the same order.
Okay, we have one more. Are the work orders JDE tables updated directly when data is replicated to the ERP? How did you manage a situation where the work order is updated manually in JDE and then you send data to be updated? Which data wins?
Right. So in this case, when we have our work order being pushed down to DSI, we have a specific status that work order enters into. This particular status is it's when it's pushed out to the mechanic, to the field user. Once it's in that status, the business rule states that it's up to DSI to be able to move it into that next status. So while you can update a portion of the work order still within JDE, it's whoever updates it last will win. So you can that's how our particular application does this process. But there's other things that you could possibly do. You could also take a look at the updated timestamp from the JDE side to determine whether or not that record has been updated before actually committing a transaction. That would require your application to probably do a sync before it sends up any transactions. That way, if you do a sync, you can pull down the latest record and check whether or not it's been updated since the user has worked on it. And then if it hasn't been updated, then the user can go ahead and commit those transactions and send it back up.
Right. Okay, that's
And then
perfect. Can you share any challenges with partial replication in a distributed user environment?
So partial replications, typically the way that the replications work in DSI is that the data will first go into our DSI database. And then when users do a partial replication, they're actually pulling a subset of that data. So one user's partial replication may not be exactly the same as another user's partial replication. We tended to only pull down the data that is pertains to that particular user. So if the first user has work order 1, 2, 3, he'll pull down only the information that applies to that work order, and then someone else who isn't on that work order won't see that information. So that's one way to kind of separate out the partial replications if you have multiple users.
Okay, I think we don't have any more questions. You have addressed everything.
Okay.
So just in case you do have other questions, once we are done with the webinar, feel free to email us your questions and we'll try to respond to them. Also, I think a recorded version, this webinar is being recorded and a link will be sent to you so you can review our presentation at a later time. Well, thank you very much for joining us today, and I hope the presentation gave you some useful information. And we enjoy building applications with using DSI, and we just wanted to share this with all of you. Thank you.
Thank you.